So hey guys, we are back with another video, and this video is again going to be about one of the research papers that was recently released by Microsoft. So I think you guys can probably get the link to this paper in the description as usual, and you guys can also open it side by side, and we can start the discussion. So overall, this paper is a survey about the RAG pipeline that we already know. We have talked about it previously on a lot of videos, and what it is saying, it is a comprehensive survey on how to make your LLMs use external data more wisely. Now, the best part what they have did is they have divided the paper into four specific type of differentiation that they are doing for the query part. Cool. I think we can start now. Now, if you see here, what they are saying that the work of this particular paper is to make sure that the bottleneck that most of the companies or organization face is regarding query, right? If you see here, the work aims to help readers thoroughly understand and recompose the data requirements and key bottlenecks in building LLM applications, offering solutions to different challenges, and serving as a guide to systematically develop such applications. I'll zoom in to make things more clear. Now, if we will go one by one, we will get to know what they are saying. They are saying there are currently many challenges faced by us, right? But few of them are regarding the query analysis. So if you see here, data augmentation LLM applications can take many forms ranging from the frequency in answers to domain specific data. Now I don't know, but most of the time people by putting these equations make the papers a bit more complex for beginners. But because I know particularly some interns who have been working on reading papers, but they after seeing these equations they don't even read the guidelines and what is the explanation, and they think okay it's out of context for them, but it's pretty easy. So yeah, in general advice, if you see some equation and if you guys think that okay this equation may go out of your mind, over your head, please go and read it once. If you are not able to understand, go and use chat gpt. Why is it for? So most of the times, 95% of time, you guys will be able to break it down if you go step by step. Now similarly, what they are saying here, that currently the formulated thing is you have this function, right? And there are q, a and d. So it's really simple. The user input is the q is query, and the expected response is the answer a, right? And the given data is d. So this is how you reach your answer, right? Or on query, using the current data on a specific query, you are reaching the answer, right? Now the four things that they have divided is there are four type of queries. One query, the first type is one which contain explicit facts, which is pretty clear. Let's say, where will 2024 Summer Olympics be held? It's pretty clear because it is targeting a contained fact in an external data, as they are saying. Second is implicit facts. What are these? Let's say, for what is the majority party now in the country where Canberra is located? Now, the first point where the model needs to get that point is where Canberra is located. What is Canberra? We need to combine that along with which party is in majority in that country. So that is what they're saying. We have to combine the fact that where Canberra is in Australia with the information about the current party, majority party in Australia. So that's the thing we need to do. Third type of query, which is interpretable rationals. What is this? This is where the hard point comes for both LLMs and customers, because in most of these cases we don't have explicitly one information where we need to focus, or multiple information also. We need to consider some previous historical data that we have, and on the basis of that we may need to make some assumptions, okay, that this can be correct. Now if you see here, how to follow external rational and how to discover hidden rational, these are the 2 points the pain points that are faced currently by users. Now last point is hidden rationals. This is the most challenging category, obviously, where here not only to implicit reasoning chains and logical relationships, but also to inherently challenge and non-trivial task of identifying and extracting the external rationale required for each specific query. So it's a very good example here they have mentioned. Suppose a cloud operation team may have addressed numerous incidents in the past, and now they are going to ask ChatGPT that let's say I am facing this particular type of issue. How can I resolve it? What is ChatGPT going to do? It is ChatGPT is not a good example of this, but the reason I'm explaining is how it currently does. So it is going to produce some tokens on the basis of knowledge it has. But in RAG we don't do this, right? We on the basis of some retrieval we get some data, then we pass that data along with the query to the model. Now in this case, because this issue is the first time issue. It won't be present in the documents, obviously, right? But on the historical data that we have, let's say all the people usually keep a track of data of the problems they have faced and how they got a solution for it. On the basis of that, model can produce some answer that okay, this was the previous incidents that happened, and this is how employees were able to resolve it. So this is how you can also resolve it. Maybe it should work. So something like that. Now you can see this. They have provided a wonderful chart here. So yeah, providing facts and providing rationals. These are two categories that basically they are dividing, and inside there are two subcategories. The first is explicit fact and one is implicit facts. Pretty clear, right? And inside this also we have interpretable and hidden, right? Now if you go one by one, we are going to discuss the type of queries. The first is pretty straightforward explicit queries. We don't need to do much. The only problem we sometimes face here is the data dependency, right? Because we are solely relying on the data that we have in our vector database. So some satisfactory common data set providing facts, you can use this data set for testing. And this is the same equation telling the dependency of the data that our current model and query have. Now how we can, the challenges that are faced: data processing difficulties, data retrieval difficulties, and evaluation difficulties. So I think these are not explicitly for this query, but a general RAG problems that people face, right? Because the purpose of RAG is to handle at least these type of queries, simple queries, which let's say what method was used in paper X to solve problem Y. This is a very direct query, right? Now what's the AI strategies of company X? Very direct query. So we have some options available. You can do multimodal document parsing. I have discussed about this before. We also have one table parser specifically designed for parsing the content of PDF which contains table to our vector database. And similarly you have other techniques where you convert visual content into textual or attributes description. We also have one parser specifically for places where visual content is there, right? Similarly chunking we need to do. So these are very direct answers for parts where RAG is not working. And then you have indexing, then you have retrieval. We have talked about these in past. The many type of retrievers are there. You can use llama index retrievers, you can use LangChain retrievers, then you have techniques like TF-IDF, BM25. You can use dense retrievers, and you can combine both of them, right? You can also do re-ranking. How re-ranking will help? It is going to re-rank your research results according to the query. So that will help you a lot. Now, see, yeah, re-ranking and correction, cool. Now, there are three type of query document alignment, right? One is you have query encoder, the query embedding, and you directly on the basis of cosine similarity get some data. Then you have this synthetic doc. Now, what is this? You are generating some kind of let's say answer using LLM, and on the basis of that, then you are getting some cosine similarity and then producing the final answer. Similarly, you have a number of synthetic queries. Similar queries you are producing using an LLM on that one particular query that you have. So and then you get cosine similarity on the index database and get your answer. So I think flare and hide, these two are really good things. I think they must have mentioned it, hide and flare, because these two are currently the best methods if you want to test these two type of queries. They are explicitly frameworks and you can architecture say. Second type of queries, implicit fact queries. Now these are very important, because from here you will start seeing that simple RAG systems will start hallucinating or will stop answering. How are you going to tackle this? Simple as that. We have data dependency a lot, but the queries change. How many experiments have sample size greater than 1000? So the first thing you need to see is the sample size, how many experiments are there total. Then out of them, how many have sample size greater than 1000? Two things are there. You are combining two of them. Then what are the top three most frequently mentioned symptoms? First you need to see frequently mentioned symptoms, and then out of those frequently mentioned symptoms you need to get top three. So you are seeing we are combining sort of the two questions together. Now at this level queries will still resolve around facts, but the answer are not explicitly present in a single text. Instead they require combining multiple facts, right? So you can have adaptive retrieval volumes. You can coordinate initiation between reasoning and retrieval. So yeah, that you can do. For the solutions you have you can say iterative RAG, where you do planning based. So it is similar to multi-hop RAG tasks we have discussed in previous videos. We have IRCOT, the chain of thoughts and everything we have. And I think currently they also have come up with new processes where you have, I think I was talking about this graph tree question answering. So you have traditional graph, knowledge graph, right, where you have specific information plotted accordingly. With the help of that, you will be able to retrieve the information in a much better way, right? This is very good when you have data in a much better format rather than split it alongside multiple type of PDFs, I would say. Then you have data chunk, graph tree. I think now they have come up with chain of thought, graph of thoughts, and even tree of thoughts, I think. So these have also come up with. And you can also combine SQL with this when you are working on this specific things where you are combining two types of answers, right? So it also works. Now, discussion on fact queries, whether to use fine tuning. This is a very important problem because most of the time when you have trained your model on this type of, you have not trained your model on these type of things, that it is not able to combine answer of multiple questions, then your model will start hallucinating or will stop answering. So you need to make sure your model has the ability to make sure it is able to answer places where a question is asked and two facts need to be combined together. So yeah, whether to separate different levels of fact queries, that is completely, I would say, optional to the client or organization that you are dealing with. But I would say this can result in suboptimal performance of LLM. Therefore, it is advantageous. Definitely, it is advantageous. But I would still say this is totally based on the client you are dealing with, because sometimes what is happening is you have multiple type of queries that are coming to you. Maybe some are mathematical. Maybe some are you can say customer support queries. So you need to deal with them accordingly. Now the second last is interpretable rational queries. This is where the problem starts, right? These queries demand not only a grasp of factual content but also ability to comprehend and apply domain specific rationals that are integral to the data's context. I'll show you. What is happening is you have questions like this: how should a patient with chest pain and specific symptoms description be diagnosed and treated given a chest pain management guideline? Similarly, how to respond to a user's question in a real life scenario given a customer service workflow? You see here, things are not very direct here. You cannot go and directly get your data from cosine similarity and expect the model to give a perfect answer from that. You need to have some assumptions, you need to have some rationals here, right? And that is where we face a lot of challenge. Now for this, prompt optimization cost is one thing. I was not expecting them to put it here. So prompt tuning, definitely I think prompt tuning is very important. I think people use chain of thought specifically for these type of queries, because you never know what type of query you will get from customer, right? So chain of thoughts is going to help you a lot. I remember a prompt specifically for one customer that was a 3-shot prompt, and the target was, the prompt was to handle at least all 3 type of queries that can explicitly come from that particular client, right? Now for this you also have frameworks like Tempera framework, which designs prompts incorporating limited instruction examples and verbalizers with action space of reinforcement learning. So sounds cool, right? And similarly, recent advancement that they have mentioned, you guys can go and read the papers. Then you also have prompt optimization, that is OPRO, that employs an LLM both to generate new prompt solution based on historical data and their associated performance metrics. So yeah, cool. Then you have this chain of thought prompting where you tell the model I think a lot of things which are going to help the model achieve, I think not state of the art, but at least the perfect near to perfect answer, because in those cases you're going to cover almost every single case that the model can face. Not all, definitely not all, but at least all cases. Then you have tree of thoughts, graph of thoughts, a lot of techniques that you guys can use here, right? So while manual design of chain of thought is highly effective, it requires substantial human and temporal resources to reduce this cost. Automate chain of thought proposes a technique for generating augmenting rational chains from minimal label data set. So yeah, another paper which is going to be fantastic if you guys are thinking of reading. Now moving to the fourth one, hidden rational queries, the toughest of them. And the questions you guys will understand, okay, it's really hard for even a human to directly answer without some given context. So how will economic situation affect the company's future development? Now here, the model first need to realize why the company is facing economic situation, like what is the current situation of the economy in the company. then what is the future goals of the company, and how the current economic situation is going to affect it. So you see, two things are there, and then you have to, using those two things, you have to assume third thing for the customer. So similarly, how to achieve 24 points using number 5, 5, 5 and 1. So you see here, it's sort of a permutation combination, I would say, answer they are expecting from a model. And it's not tough, it's not like tough, but until unless model knows that okay, this is a type of question that can be fed into it, it will face problems. So fine tuning can help here definitely, but chain of thought can also help here, but till a point only, right? You never know what kind of problem can come in this particular part, and you never want your model to hallucinate, even though it will. But obviously, as a person who's working on these models, you want your model to not hallucinate on these type of queries. So does Afghanistan permit a parent to confer his or her citizenship on a child born abroad? Just see, guys, this is, I think, toughest type of queries you can give to a model, because you are asking 2-3 things, then the model is going to read get the data for 2-3 things, and accordingly it is going to produce some rational answer for that. Yeah. Now for the challenges, obviously retrieval is one of the biggest challenge. The data inefficiency is very, very big challenge for this, because the query that you are asking, it's a very high chance that the legit data won't be present here. There will be some kind of previous data that is going to be there, and then the model is going to produce some rational answer on the previous data that it has, right? For this you have offline learning. For generating regional rationals from work like star and LXX used LLM in rational generation, but still I would say not that effective, even though they have shown improvements. Then you have leap, then you have GL that identifies errors and generalize them into guidelines for future tasks through in context learning. So then you have RACP that uses mistakes from training data to generate high level reasoning and specific insights, right? So you also have some integrated methods like medprompt that include GPT-4 generated chains of thought for training examples with self validation. So it's a very good approach, I would say. Agent learning is coming to the play, but I would still take some time to comment something on that, because I think currently the agent things that are happening in the field are specifically toward application part of the user, and not specifically for customer side. That is going to help them a lot, because application is where you can use the agent, because there are specific set of instructions. But when it comes to dynamic prompting for user, I don't know how it is going to perform. Similarly, in context learning is there. Then you have fine tuning for the model. Definitely fine tuning is going to help here you a lot, because you need to know when your model needs to answer and when should it say sorry, I cannot answer, right? Summary of main techniques for different realization. Then you have iterative RAG on graph, text to SQL. So these are, I think, specifically for levels, level 1 to 2, 3 to 4, right? So yeah, guys, that was it for the video. On the conclusion, you guys can read. It's a very good paper, and I would highly suggest you guys to read this paper and one more paper that came, I think, last year, this year only, okay, July. This paper, searching for the best practices in RAG. This is also a very good paper when it comes to RAG techniques that you guys can follow every time you are experimenting on different aspects of RAG. So yeah, so thank you guys, have a nice day.